Thank you, everyone. Okay, so I have a question for you. Do you have a side gig? You know, something that brings in a little extra money each month. Well, I do. By day, I'm a product manager for a software team in a bank. But by night, I'm a private investigator. And what is it I investigate? Ruby cases. No, not jewel theft, the programming language. And why did I decide to go into private investigating? Well, there's been rumors of a shady mastermind causing havoc and confusion amongst Ruby developers worldwide with his constant meddling in the source code. And I wanted to put a stop to it. So I decided that I couldn't do this job under my normal name. I needed to protect my identity. And so I chose the name Deirdre Bug. Why? Well, for the sole purpose of making this joke. And today I want to tell you about one of my more memorable cases, the case of the missing method. Chapter 1. So I'm sitting alone, bored in my office, my flat, and the doorbell rings. And it's Mike, and he doesn't look too happy. But first, let me tell you a little bit more about Mike. He was an acquaintance of mine. We had some mutual friends. We saw each other now and again. He was 24 years old, a junior Ruby developer, and he got excited about test-driven development. And he'd been applying for an apprenticeship at the prestigious Ruby Institute of Professionals. And he'd managed to get through all of the stages, beating hundreds of applicants to the final stage, and it was happening in 2 days. And there were 2 people left fighting for the final spot, himself and a woman named Jenny. Let me tell you a bit about Jenny. So she was 27 years old, also a junior Ruby developer, and she loved all things Rails. And she's also Mike's best friend and housemate. And they had quit their consulting jobs to enter the world of tech together, and not long after also decided to live together. And for the interview, they'd agreed to work together to prepare so that they each had the best shot. May the best person win, they'd said. And they'd been asked to research a series of topics that they were going to be grilled on. And one of them was method lookup. And they'd assigned this topic to Jenny. And this is where Mike said, something doesn't add up in Jenny's notes. But the problem was that Jenny had been so stressed and panicked, rather uncharacteristically, by the whole interview process that she wouldn't hear Mike out. She's convinced that she's right and that they don't have time for Mike's concerns. And so Mike tells me that I can help him find the answer, because then he'll have what he needs to confidently correct Jenny's notes and save them both from interview failure. So he reaches into the satchel and draws out some sheets of paper in his hand. And they're Jenny's supposedly flawed notes. And so I ask him to walk me through them. So let me describe to you how they worked. So she had these boxes which represented the concept of a Ruby object. And each of the Ruby objects had a label called class. So this acts as a reference to the parent class of the object in question. So some objects were instance objects, and the class label for them referred to another type of Ruby object, which would be a class object. Class objects also had their own class label, but they also had a methods label, and this pointed to a table of all the instance methods for that class. And then there were some handwritten notes which said, any class you define is an instance of a class object called class. And so if you were to write class Cake in our code, we're creating a class named Cake. It's an instance of another class object, and that class object is called class. So all classes are an instance of class with a capital C. And then Jenny had this code in her notes. So it was a class called Cake, and there were 2 methods. An instance method called Tasty, which returned true if the flavor of the cake was carrot, and this made a lot of sense to me. And there was also a class method called Edible, which returned true. And then Jenny said, imagine we had a cake instance called carrot. This is what we'd see. We'd have our Ruby object called carrot. Its class label would point to an object called cake. It would also have its own class label. It would have a methods label, and in that table, we'd see the tasty method. And the class label for cake would point to a Ruby object called class that would have a methods table, and that would point to edible. And then Jenny had written, a method definition always comes from an object's class. And this is where Mike shook his head with frustration and said, it cannot be that the edible method lives on the parent class for all classes. Can I show you something, he asks me. So he asks if he can jump on my computer. I say, okay. He opens up a terminal, goes into Pry, and he loads in the Cake class. And he shows that the class for Cake is class and looks for all the instance methods and sees if he can find edible. And it's not there. What a mystery. And at this point, I'm pretty stumped. But I think if anyone can take on the challenge, it's Dee Bug. And besides, this meant a lot to Mike. He was going to pay me handsomely. And so I decided to take on the case. Chapter 2. Ever heard of Google? Or, if you care about people like me not spying on you, perhaps you use DuckDuckGo. Yeah, well, when I'm Dee, I don't believe in these tools. I don't trust them. And it's no coincidence that with this approach, I've become the best Ruby PI the industry has to offer. And so what did I have? Books. Books, books, and more books. And I spent a whole day quickly skimming a load of books, but I couldn't find anything useful. And so I decided to form a hypothesis and go from there. So I said, the edible method must be somewhere in the ancestry tree. And what's the ancestry tree? Well, it's all the classes and modules that a class inherits from. So it's all the possible places that you could find a method. So this is what it was for Cake. And I constructed a where method, which took an object and a method. And it searched through all the ancestors of that object's class. And it looked for the class where the instance methods of that class, and only that class, included the method that I was looking for. So I decided to give it a go. And I started with something that I knew would work. So I created an instance of the Cake class, called it Carrot, and I looked for the tasty method. And I knew it would be on Cake. And now it was time to find the edible method. What? It was nowhere at all? What a mystery. And so at this point, I'm confused, and I think it's time for a change of scenery. So I decide to head to my favorite co-working space. And here I feel at home. I'm surrounded by people hacking away, and I quietly settle down. But because of my naturally inquisitive nature, my eyes couldn't help but stray to the screen of the guy next to me. And I saw that he was playing around with something called ObjectSpace in his terminal. So I asked what it was, because it looked interesting. And he said, well, it's a way that you can interact with all the live objects within a Ruby session. For example, if you were to type this in, you can count all the live class objects that you have in a session. So I decided to take a break and have a little play. So I went to IRB, and I typed in the command. So I had 936 classes. So I thought, let me create one class and see that that number goes up to 937. 938, that's strange. Let me try again and check that the same behavior happened. So I created another class. 940. It kept on going up by 2 each time I created one class. What a mystery. But I couldn't spend too long thinking about this, because just then the phone rang, and it was my friend wondering where I was. You see, I'd completely forgotten that I'd agreed to go to a tech lecture with her, and I was anxious that I really didn't have much time because I had to solve this case, but I'd been canceling on this friend a lot lately. And so I decided that on this occasion, I should make time for her, and I rushed out of the door. Chapter 3. So I remember arriving at the lecture just in time. And it was a lecture about the language Smalltalk. And I wasn't interested in this at all because I only have space in my heart for Ruby. But as I said, I was there for my friend. And the lecturer started by talking about how Smalltalk had been created in the 1970s, and it had led to the birth of object-oriented programming. But it wasn't long before I lost focus. I couldn't stop thinking about my play with ObjectSpace. Why every time when I created one class were 2 objects being created? Psst, pay attention, my friend said, noticing I wasn't focusing. So I looked back up at the lecturer, and she was asking, well, what is the class of a class in Smalltalk? And she had this code on the screen, and I wasn't really following, but I could see that she had asked what's the class of this polygon object she had. and it had returned polygon class. And she said, well, what will I get if I ask of the class of the polygon class? And it returned something called meta class. The class of a class is called a meta class, she reiterated. And then she went on to talk about how all the languages that have been inspired by Smalltalk each have their own concept of a meta class. And this included Objective-C, Java, Python, and Ruby. Ruby. Something clicked. One class, two objects. And so I made my apologies to my soon-to-be no longer friend and rushed out of the door, home to my terminal. I decided to try my luck straight away. Of course, that would be too hopeful. And so I thought, let me look at all the methods on the Cake class. And this was proving to be a bit overwhelming, didn't know where to start. So I thought, let me filter this down to all of the methods that have the word class in them. And here, two methods looked interesting. One was superclass, and the other was Singleton class. So first, I wanted to remind myself of the ancestry tree for Cake. And then I thought, let's see what superclass gives me. So I knew this wasn't what I wanted because object already existed in the other ancestry tree, and we already knew that the edible method wasn't in that ancestry tree. So I thought, let me try Singleton class. Ooh, this was different. I hadn't seen this before. And when I looked at the ancestry tree, not only did I see this new object that I hadn't seen before, I saw two others. And I thought, perhaps the edible method lives on one of these. So I went back to my where method, and I edited it so that rather than looking at the ancestors of an object's class, I searched for the ancestors of a Singleton class. And then it was time to give it a go, the moment of truth. And I found that the edible method lived on the Singleton class. And I thought, let me just confirm what's going on here. And in my excitement, I struggled to type properly. But I got there eventually. And I confirmed that the edible method lived on the Singleton class of Cake. Case closed. Chapter 4. So at this point, I was super delighted. I was excited to share the news with Mike. But I also took a moment to wonder, maybe I should retire, because this could prove to be one of the biggest successes of my career. And they always say you should quit while you're ahead. But anyway, I gave Mike a call, and I asked him if I could come round, because I've solved the case. And he was excited. He said, of course, and he'll have the notes ready and waiting for me. But although I'd solved the case for Mike, I wasn't quite satisfied. I just discovered a whole new concept in the language that I hadn't heard of before. What are Singleton classes? And so instead of going directly to Mike's, I decided to take a detour and visit a friend of mine. Her name was Ellen. She was 43, a freelance developer, and she regularly contributed to the Ruby codebase. She knows everything there is to know about Ruby. And so I proceed to tell her all about the case. And when I'm done, I ask her, so what are these Singleton classes all about? And she says, well, they're hidden classes created internally, behind the scenes in Ruby, and they're there to hold methods defined only for one particular object. So she said, remember how you told me about your carrot instance of the Cake class? Well, its Singleton class would only hold methods for the carrot instance. And if you had another instance, say, called red velvet or chocolate, you wouldn't find those methods on those objects. So I said, okay, given that they're working behind the scenes, when does knowing about them become useful? Ellen thought for a while, and then she told me about one of her recent clients. They were called Budgeting Inc., and they were building a clever artificial intelligence machine learning personal finance tool for small business owners. And they were expanding globally, and they needed to roll out slightly unique versions of their software for each new city that they entered. Ellen told me how she was horrified the first time that she saw their code base. Different developers had been responsible for each new city, and it looked like each time they were trying a different attempt, whether it was naming things, testing things, designing interfaces. And this meant that there was lots of duplication in the code. Therefore, there was lots of time that had been wasted on development because people were reinventing the wheel and often not doing a very good job. And this meant that there were lots of bugs. Some things had been copied hastily, whereas other times things had been left out. So it was difficult to see what was important. So the developers were unhappy because they had a lot of tiresome work, and the cognitive load for getting stuck into each new situation was pretty high. And the product owner was also unhappy because delivery was either very slow or it was quick and things were bug-ridden and other things were missed out. And so Ellen wasn't quite sure what to do until she decided to create a DSL, a domain-specific language. And she asked me if I knew what she was talking about, and I said I had no clue. And so she beckoned me over to a computer and said, well, let me show you a basic version. And so she opened up a price session and input this class. So it was called city instance. It had a construct method, a class method, and it took a block. Then there was a variable called city, which called out to the initialize method via new keyword. And then we called instance eval, passing in the same block to city. And Ellen said I should pay attention to this line because it would become useful later. And then we return the city object. Then we have an attribute reader, which sets up a variable called taxes. We have the initialize method that instantiates a taxes collection. And then we have a method called tax, which takes a name, and that pushes that tax into the taxes collection that we created earlier. So Ellen says, let's use this. She creates a city, New York, and she adds a couple of taxes. And then she prints out the taxes. And she says, there you go, that's an incredibly simple, lightweight DSL. And we can keep quickly spinning up these objects. And then she said to me, well, imagine if we had other properties, not just taxes, things like lists of banks or finance schemes in a city. Or imagine if we had more information about each of these properties. So here we've just given the tax a name, but what if we added more information like thresholds and rates? And so using the beginning of this simple framework, it wouldn't be hard to keep extending these city instance objects to make them incrementally more complex. And then Ellen said, well, imagine taking that to the next level. And imagine interacting with a city instance class in the same way that I did on the command line, but this time, instead of just having variables in our price session, we're spinning up behind the scenes new subclasses of city and other related models such as tax, scheme, bank, anything that you list. And so Ellen explains to me that this was the sort of thing that she had produced for Budgeting Inc., which was a DSL that allowed for quick, easy scaffolding of each new city and the related subclasses. And so she said, well, we know how to spin up identical cities now with different names and different taxes. But what if there was one city that had a particular quirk? So she asked me to think of a city, and I chose one from Bath, from the UK. And I suggested a tax, which was afternoon tea tax, because people in Bath like afternoon tea. And then she asked me to think of something in the UK that people don't really like. But she didn't really like my suggestion. She thought it was a bit controversial. And so she chose something a bit more safe, which was the fact that it rained all the time. And she said that when it was a rainy day amnesty, all the taxes in the UK were cleared, or in Bath were cleared. So she created Bath, she printed the taxes, and then she called the rainy day amnesty. And now we can see that there were no more taxes in Bath. And then she said, remember our friends in New York? Well, they heard about this rainy day amnesty, and they want in on it. But unfortunately, they can't. It says undefined method, rainy day amnesty for city instance, blah, 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 blah. And what is this stuff at the end? Well, Ellen called Singleton class on New York, and we saw that it returned the same thing. So the code was looking for the rainy day amnesty on the Singleton class. So when we start playing around with DSLs and we use methods like instance eval, that's when we start leveraging the existence of Singleton classes. Because when we called instance eval earlier on in the city instance class, what that is saying is for any methods passed into the block, define those on the Singleton class of that object. But Ellen said, let's take a step back for a minute to the high level. And she told me about how when she created DSL like this, it enabled the developers to spin up each new instance effortlessly. So she had managed to abstract out all of the key similarities between any city. And the developers now had a frictionless way via the command line to spin up the foundation that they needed. And the code base was much better maintained because all of the scaffolding had already been tested very well by Ellen once, and nobody had to worry about it again. In fact, the developers could now just focus on the interesting bit, which was customization required for each new city. And the framework of the DSL made that a lot easier, and the scope was much more refined. So now the developers were happy because they were interacting with a system that was a joy to use, it was much easier, and they could have a high-level overview of the whole domain in their head just because of the documentation for the DSL. And the product owner was also now happy because there were far fewer bugs, faster delivery, and she could also speak in the same language that the developers were by expressing new requirements using the language of the DSL. And now let's go back to the topic of the Singleton classes. So why is knowing about them useful? Well, Ellen says that one of the main reasons she was able to complete the project to such a high standard was because she understood exactly where she was defining methods at any minute. Because once you start entering the realm of dynamically creating methods and classes, the class hierarchy and method lookup changes. It becomes more interesting. It becomes different, and as I had noticed in my own investigations. And so you may get error messages like the one we saw before with New York, and you need to be able to spot where Singleton methods are becoming involved, because then you know where the methods are hiding, and it saves you a lot of time when you're trying to fix issues. And then Ellen turned to me and she said, well, for example, do you know what the class of a Singleton class is? No clue, I said. And so she told me to go investigate that as homework for when I had a break from my other serious investigative duties. And then she said, but beware. So I've been talking a lot about DSLs, but they're not the answer to everything. If you find yourself in a case where you've got complex, repeated business rules, and perhaps you need to customize behavior for some specific instances, then consider DSLs as an option. But even then, approach them with caution. It can get complicated quickly. But you don't even need to be writing DSLs for it to be beneficial for you to understand the basics of how they work. So she said if you're using Rails every day, then you're seeing DSLs every single day. She went to the Rails Guide's website. Active record migrations, these are carried out via a DSL. So when you talk about what you want to do to a table, what format you want your columns, that's all via DSL. When you're specifying how your Rails apps want to handle HTTP requests, that's also done via DSL. And I realized that I myself had been doing all this stuff by rote, and I never stopped to think about what was happening behind the scenes every time I typed in the resources keyword in my config roots.rb file. And there's many more of these in Rails. And so Ellen said, when people talk about Rails magic, it's not really Rails magic. It's more a collection of well-written DSLs. And then Ellen said to me, I hope you're TDDing all of the time. I said, of course. What do you take me for? And so she said that with RSpec, with its describe, context, it blocks, those are all DSLs as well. And so with all these Rails and RSpec DSLs, when you know about Singleton classes, it can be very helpful. Because you might find yourself in a tricky problem. You can't make head or tail of it, particularly if you inherit a code base from somebody else. And so if you're seeing a funny bug and it's to do with methods, you never know, Singleton classes might be involved, and having them as part of your suite of debugging tools can be very useful. And so at this point, I was feeling very leveled up by this conversation. And armed with this new knowledge, I went over to Mike. But when I arrived, I found a Mike who had tears in his eyes. He'd obviously been crying, and he couldn't look at me directly. And I noticed that he had crumpled pieces of paper in his hand, and they looked exactly the same as the notes of Jenny's that he'd brought me the other day. So I took them from him and had a look, and I couldn't see what was wrong. We had an object, a carrot object, with the class label. That pointed to a cake object, which also had its class label, its methods label that had the tasty method in the table, and the class object, which had the method edible. But wait, it didn't say class like last time. This time, it said cake singleton. As Mike saw me notice this difference, he fell to his knees and broke down in tears. Jenny knew about singleton classes all along. He'd gone into her room to find the method lookup notes in advance of me coming, and this was the copy that he'd found. I, for one, was disappointed in myself. I'd been so focused on the main villain, the shady mastermind, that I'd failed to spot another villain right under my nose. My best friend tried to sabotage me, Mike cried, and he started wailing and saying that he wasn't going to go to the RIP interview. And I said, no way, you can't give up now. And I gave him a comforting pat on the shoulder, and I said, you can do this, and I have just the thing to help set you apart from Jenny. And he looked up at me hopefully, and I said, have you heard of DSLs? And I proceeded to tell him everything that Ellen had just shared with me. And although Mike still looked devastated when I left, I had confidence that I had inspired him with the power of Singleton classes, that he'd pull himself together and go and secure that RIP internship for himself. So 2 months later, I managed to drag myself to a hack night. And I'm standing in the room and I hear two people whispering. They're saying, ooh, that woman's Ruby famous. And I look across to where they're looking, and who do I see? Ellen. So I walk over, we catch up, and I tell her that I've been reflecting on the case of the missing method. And I had my takeaways, Singleton classes that are there to hold methods defined for one particular object, and that when you understand them, it opens up a whole new world, particularly when you're entering DSLs, dynamically creating classes, metaprogramming, all that stuff. But I still feel like day to day, I can get by ignoring them. So do I really have to care about them? Not really, Ellen says. Like you say, if you're using DSLs, then yes, you definitely need to know what's going on. And they do underpin popular frameworks like Rails and like RSpec. But day to day, you can get by. However, understanding why Singleton classes are there is super interesting and empowering. Think of the Ruby core team. When designing the language, they wanted to keep things as straightforward and as simple as possible. And by simple, I mean that they wanted to minimize special cases. So they wanted to aim for having one way, one pattern for doing things. They asked themselves, how consistent can we get things? And if you think about methods in Ruby, they can only be defined in one of two places, or they are only defined in one of two places: a normal class object or a singleton class. And really, every method in Ruby is an instance method, because class methods don't fundamentally have any different behavior to other methods. It's just that the things that we call class methods are really instance methods, where the objects in question are a class, and the method is stored in the class's singleton class. So this is a fundamental way to how the Ruby object model works. And so she says, yeah, singleton classes, they're invisible, but they are everywhere. They're a key foundation. And so I left the hack night deep in thought. Ellen had inspired me to explore more of Ruby behind the scenes, because there was so much that I didn't know, and I had only scratched the surface. And I'd always been a general Ruby private investigator, and I'd been successful. But perhaps it was time to find a niche to help me reach that next level. Thank you.